Ladies and gentlemen, I'm honored to introduce Dr. Kevin LaGrandeur, a distinguished fellow and professor at the Institute of Ethics and Emerging Technology. Dr. LaGrandeur expertise in science, technology, and society, particularly in technology and ethics, has garnered global recognition. His extensive contributions, spanning more than 50 articles, media productions, and two influential books, Artificial Slaves and Surviving the Machine Age, showcase his profound understanding of these domains. Today, he will shed light on brain-computer interface and ethical consideration intertwined with these groundbreaking technologies. Specifically, he'll discuss the fusion of BCI with AI, highlighting experimental use in emotional therapy for psychiatric patients. Dr. LaGrandeur will delve into the ethical quandaries surrounding these advancements, exploring potential resolution that corporation-engaged AI-based applications should consider. His insight promised to illuminate the ethical dimensions of these transformative technologies and their implications for society, marketability, and corporate ethics. Please welcome Dr. Kevin.
Hi, everybody. Thank you for showing up after lunch. I know it's a tough time for everybody. I get sleepy after lunch. Not up here, I won't, but in your place, I would. So thank you for coming. I actually my titles have changed a little. I still am with the Institute for Ethics and Emerging Technology, a think tank based in Connecticut, but I now have left my university and have become the director of research for the Global AI Ethics Institute, which is based here in Europe. I do it remotely. And I'm also now have a consulting business in AI and ethics. So I'm going to talk today about brain-computer interfaces. First, I'm going to talk about what the heck they are and how they work. And then I'm going to talk about what they have been traditionally used for, and then what they're being used for more recently, which is psychiatric therapy. And then I'll finish by talking about some ethical issues that come up when it's used as psychotherapy and how the company that makes it might address these ethical issues in order to make themselves less vulnerable to criticism and regulation, and to save money. All right, so to get started, let me talk about brain-computer interfaces, what they are. BCI, as it's known, is simply a connection between the brain and a computer, and that connection can go one of two ways. It can go outward, that is, you use your brain to control a digital device or a digitally based device, sometimes with AI involved in it. And then the other way it's used is for input, and that's typically to modulate the brain. It's called neuromodulation. The input is from the digital device, sometimes coupled with an AI, in order to control some aspect of the brain that's gone haywire. So the newer ones that include AI are used in a couple ways. From the brain externally to a device with AI is used, for instance, to help control and actuate artificial limbs, the more modern ones. And you can see here it's done by either using a sensor cap, an EEG, or more radically to implant sensors into the brain tissue. It's also used, for instance, for people with locked-in syndrome who can't communicate because they have some kind of nerve disorder. Stephen Hawking, the former physicist, this recently deceased physicist, had, for instance, ALS, if I remember right, and he couldn't talk. So in his case, he didn't have to use an AI-based actuation because he had ability to move a joystick with one of his hands, and he would spell out words, and then they would come up on a screen, and a voice synthesizer would say the words for him. So the new wrinkle is that with brain implants and AI activation, you can now think about the word or writing the word, and the AI learns how to sense the neural impulses that your brain puts out when you do that, and then it translates it into writing on a screen, or a voice synthesizer can say it for you. Right now, if you'll notice, this is kind of invasive with these open skull surgeries that they have to use to put them in. That is something that Elon Musk and his company, yet another company, Neuralink, is trying to solve by creating, down the road, they want to create a Wi-Fi based antenna that they can implant in the brain non-invasively by going through the carotid artery. Musk calls this neural lace. It's a very, very fine mesh that can fit into a syringe and through the needle of a syringe. And it would travel from the carotid up into the brain, unfold, and incorporate with the brain tissue over a period of about a week. Now, this already exists. Charles Lieber and his team at Harvard invented this neural mesh about 6 years ago. And they tried it on rats and monkeys, and it worked pretty flawlessly with no side effects. There are a couple problems. One is they did not find a way to inject it through the carotid. That was theoretical. It still is. And other neuroscientists I've talked to have told me the problem they didn't talk about was that this mesh is attacked and broken down by the human body, and after about 6 months, it dissolves. So you got to do it all over again. When you're doing it that way, that's not a good option. All right, so neuromodulation, the other way that's what we're going to talk about the rest of this period. BCI for epilepsy control using deep brain stimulation is one of the things that's been done. There's also been neuromodulation not just for epilepsy, but for Parkinson's disease. Things that the brain causes the body to do wrong or with difficulty. So let's talk about epilepsy control. The NeuroPace company has a device that you implant like a pacemaker in the chest. This one's implanted in the brain, and it has a couple leads. One lead is a deep brain stimulator, an electrode that sends an electrical pulse to the brain to short circuit an epileptic seizure. Now, I'm using slang here. If there are any scientists in the room, yeah, I apologize for using shorthand like short circuits the epileptic seizure, but that's essentially how it works. There's a lead also that goes to the brain to sense an oncoming seizure, and then an AI interprets that and can can determine if it's a seizure or something else. And if it determines it's a seizure, the AI is the thing that initiates that pulse to the brain. The older kinds of devices like this did not use AI. They would work on a simple timer. And so every once in a while, there'd be this pulse. Or the patient would use a manual switch. And this is what it looks like implanted in the brain. You can see it's a lot of stuff to put in the skull. All right, I talked about how it works. The key thing here is it's an alternative to surgery because you thread the lead. Well, you have to have surgery to put it in, but it's as opposed to sort of radical brain surgery to try to adjust the brain tissue to stop having epileptic seizures. It's used mainly, epilepsy is the first line of defense against it is drugs, medications, but medications don't work all the time for epilepsy. In fact, they're somewhat inefficient. And I talked about these things here. So, the advantages of this particular technology, instead of scheduled stimulation or surgery or meds, first of all, it's quicker control of seizures. The AI can perceive the oncoming seizure pretty well and immediately send a pulse that will stop the seizure. Also, there are fewer side effects than other modes of control, like radical surgery on the brain. And a reduction of tissue damage in the brain, and better battery life for the mechanism, because it's not always on a timer and sending a useless stimulation pulse. So here's another type of BCI, neuromodulator for psychiatric disorders like depression and obsessive compulsive disorder. That's what they're being used for as prototypes right now. And you can see this is different. Not so much is inserted in the brain. Instead, you have what looks like a regular heart pacemaker down here in the chest. And the leads go up, thread up through the neck and into the brain, and same process. The AI senses when a depressive episode or an obsessive compulsive episode is coming on, and then sends a pulse into the brain to stop that episode. And this is, again, in place of using medications or other types of psychiatric interventions. This is a map for depression, the places that are sensed and stimulated. The scientists, through experimentation, have found that the best place to put the sensor is the amygdala, because the amygdala is the seat of most emotions in the brain. And then the stimulation goes to the ventral capsule, because that seems to be most effective in stopping the depressive episodes. So the advantages of this particular device: first of all, it works when other treatments fail. It's very successful at stopping depressive episodes. Now, we're talking about people, as with epilepsy, people who have uncontrollable, by other means, and very frequent episodes, and maybe suicidal. So the success rate is very good, and also the timing of the therapeutic stimulation is better with the AI modulation, as it is with epilepsy and Parkinson's disease. So, pretty good device. So I want to move to the ethical issues that come up here. Do that. I want to just give you sort of a baseline of ethical standards here. This one I'm using because it was done by Harvard's Berkman Klein Center, and Harvard University. Basically, they read through hundreds of white papers, reports about making ethical AI, and they distilled it down into 36 reports that they used, and they distilled that down into 9 common ethical values for making AI that all of these papers seem to agree on. And these papers were written by government entities, scientific entities, and corporations like Microsoft and Google. So they came up with these: international human rights, promotion of human values, professional responsibility, human control of technology, and so forth. Now I'm going to come back to this. But those of you who know the rules here that have been formulated in the EU, or are familiar with the ones the United States has tried to put in place, you'll be familiar with these kinds of concepts. So let's talk about some of the problems, the ethical problems that come up. Well, they're mainly problems with patient reports of problems they have psychologically being therapized in this fashion. First of all, they have problems of autonomy. The finding is that people feel this AI in their head, and they can feel it adjusting their feelings. So when you have an external thing that is adjusting your feelings about something, then they start feeling like, whose feelings am I feeling? Is it the AI's feelings, or is it my feelings, or what's going on? And that leads to the idea of agency being limited here. How much can I do before the AI intervenes? And how does that make me me versus me plus the AI, or just the AI as me? These are all things patients actually talked about. And then that all sort of wraps up into the identity problem. And that is, who am I? And patients have reported a loss of the sense of self because of this intervention. Now, some of them don't care. In fact, they think it's great. That quote there, one of them that really likes this, said, "It became me. With this device, I found myself. I could do anything." So they basically become symbiotic with the AI, and they adjust to it and actually feel like it makes a huge positive difference. But other people, patients, have said, I'm not sure what I do is me anymore. How much of what I think and feel are my thinking and feeling versus the AI doing it? And they get really disrupted by this and actually more mentally destabilized in certain ways. They get estranged from themselves. Now, the interesting add-on to this is that the people who tend to rate this experience positively are older. That is, they're over 30. And they tend to have a developed sense of self already. The people who report disruption tend to be younger and still formulating a sense of self. So we'll come back to that later as well. The last thing is, and this was the scientists' worry, not the patients really. The scientists, because they realized how they were using the brain data of patients, worried a lot about storage, secure storage of it, and worried about that brain data getting out to third parties somehow, and really compromising the privacy of the patients. So, I circled with my shaky pointer the five things that seem to be involved here ethically. The concepts are promotion of human values, professional responsibility, the part of the scientists with privacy, transparency. Clearly, some of these patients weren't prepared well for how the AI would interact with them. Safety and security, and privacy, again, going along with professional responsibility. So, if I were consulting with the company that made this device, how would I advise them to deal with all of this? All right, well, some possible solutions, and some of these may seem obvious, but they may not, and it depends who at the company I was talking to. I would start with the C-suite, the people at the top, and meet with them first and talk about define what their values are. Ask them what they value and what their aims are. Try to get them to define for themselves what they want to do and where they want to go, and then go from there. One of the things I would suggest is to make sure they do a better job of making patients understand the possible changes in the sense of self and make sure the patients can handle that. For one thing, I would advise them, it looks like the results say they shouldn't be using this on younger people, unfortunately. So avoid using patients in periods of identity formation. Also, obviously, find a way to set up very secure data storage for the brain data. And a lot of corporations make extra money by selling data about patients, which they're not really supposed to do, but they do it anyway. And they should be careful not to only not do that, but also to find a way to wall off that data so that it can't be leaked. And last, to find a way to integrate rules about brain data into current regulations. I mean internal regulations that the corporation already has or is making. And also to make what they do concurrent with government regulation. Now that's in its infancy right now, so it's kind of the Wild West. But you can still talk about it. For instance, in the United States, regarding privacy, we're having real problems. There are 12 privacy laws already stalled in the US Congress. They're just piled up in there because the US Congress is so dysfunctional. But there's general privacy standards in the United States that could be talked about in the corporation. And I would suggest with this that they have employee seminars about these privacy laws and privacy concepts, and they find people, maybe me, to conduct these. Also with the EU, the regulations, as you all know, are different and actually more advanced than they are in the United States. The EU has been pretty active in formulating regulations for AI so far. It looks to me like you may actually have an AI Act that's passed by the end of this year. So, the thing about regulations is they're not so simple, especially the EU regulations. I think it's 100 pages long or more, and tons of variations and twists and turns in the regulations. So the point here is that I would warn the company, you can't just have the compliance officer make a checklist. Did we do this? Yeah. Did we warn the patients properly? Yep. Check, 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 check. Because it's not that simple. Let's say you have two criteria you're trying to balance. You want to be careful of patient privacy, but on the other hand, you want to be able to use that data effectively, and you're caught in a corporate argument internally about how to deal with this. The EU says if there are tension in design principles, you have to establish methods of accountable deliberation. The key word there is accountable. So, in other words, you have to record your deliberations so that your compliance officer can defend the company if the EU comes and says, show us that you followed regulations here. So companies can't just use checklists. They might need consultants' help, or at least to focus more carefully on methods for deliberation that are accountable. How are they going to do that? How are they going to preserve the deliberations in a way that shows accountability? Help gathering skilled people to decide trade-offs in the company. That's important as well. And the trade-offs have to be documented so the compliance officer can defend the company, as I said. So I'm going to stop there so that we have time for questions and answers and discussion about this. More of my work's on those two websites. Those are academic websites. I have a bunch of articles on AI and ethics. I also have a LinkedIn profile as a consultant and professor, and my email's there. So thank you very much.
Thank you very much. Do you have some questions for Doctor? Yes?
You're on microphone now.
Yeah. Thanks for the talk. My question is, how do you see the balance between capitalism and the for-profit aspect of it being helpful for researching new stuff, and on the other hand, being a nuisance to the privacy and everything about that, and doing something for the good of the people?
Well, I think corporations and their money are very necessary for pushing forward AI research. I think, without corporations, we wouldn't have a lot of this AI. So I wouldn't demonize them. I think that there is a conflict of interest, though, with capitalism. Capitalist corporations are machines for making money. They're not moral, they're not immoral, they just don't have morals. So I think that's why regulations are necessary. I think they need to be balanced regulations so that we don't kill the innovation of corporations like OpenAI. And I think that what I like about the President Biden's executive order is that that is explicitly stated in the order, I think probably at the behest of the AI corporations. But I think he's trying to strike a balance there in the executive order, which, by the way, may be totally ineffective because of US law. He based the order on a 1950 law, the Defense Production Act. It's so old, and I think that the first time it's invoked to challenge a corporation, the corporation will just take it to court, and it may very well be thrown out as illegal. So what really needs to happen in the United States is US Congress has to get its act together and get some work done. So did I answer your question? I started going off on a tangent there.
Yeah, pretty much.
All right, thank you. Thanks for the question.
Thank you very much for your presentation. My question is more in a sense, can you make a parallel in a sense of using this kind of way to treat the patient and therapy via chemical components like pills and so kind of medicine that you can take to tackle, for example, epilepsy or depression? Is there an ethical guidelines? Is it comparable or it's not?
Okay, so the ethics of, say, taking Prozac, an SSRI inhibitor, versus having this kind of surgery or implant, right?
Yes.
Yeah, I think the ethical issues may be generally similar in the sense that with pharmaceuticals, you have to think about the patient's welfare first. That's already pretty well established, that set of principles for medications. And those are really led by physicians and to some extent pharmacists. So I think the part that's not parallel is this is all brand new stuff. And it's only used for people who don't respond to medications, because medications are a much more standard therapy now and much easier to use. I mean, even with the deep brain stimulator, the BCI, you still have to do surgery. It's not as radical in some cases, but it's still surgery and it's still more dangerous than taking medications. So I think the ethical issues are slightly different because of those things. Thank you.
Thank you. Do you have more questions? Yes?
Hi, thank you, Gavin. I know you showed there are 36 reports to analyze ethical guidelines. Likewise, if you look at the countrywide, each country is coming up with new guidelines. Even today, UK government has signed up another guidelines. How do we go about establishing a global ethics guideline, which is comprehensive, people understand, and so on? Thank you.
Thanks for asking the easy questions first. Yeah, global guidelines. Well, that's a big kettle of fish right there. In fact, the organization I'm now the director of research for does exactly that kind of investigation. The Global AI Ethics Institute is devoted to trying to diversify what we mean by ethics, not just using Western ethics, but, for instance, investigating ethics based on Hinduism, Buddhism, Shintoism, and other systems. So that's a very good question. I think the only way we're going to be able to form a global ethical set of rules is by a lot of negotiation. That's international, a lot of diplomacy. I mean, think about what happened with nuclear test ban treaties, for instance. That was a lot of work over a lot of years and a lot of consensus building and compromise. So I think we're going to have the same issue with AI. I don't think it's going to be fast. That's my opinion. And, we're still gathering ideas here for how to, look at the Berkman-Klein chart that I showed you. That's only about 2 years old. So it's early days.
Thank you. Do you have some more questions?
Or comments? I've been curious if there are any physicians in the audience and what they think of this, or
Yes, there is.
neuroscientists.
Yeah.
I know that There are some neuroscientists at this conference.
Yeah,
I've
we
talked to
have
them.
one question here.
Thanks. Thanks, Professor, for the presentation. This is a little bit the more sci-fi question, actually. I'm just curious, whether you think, is there any possibility for AI one day to learn someone's personality and to leave that to their kids and afterwards, if you know what I mean? So to learn some kind of whole emotionally, psychological, rational structure of one person. And so, because what AI do is it imitates. It's just a model of some reality. It learns of something. Do you think that one day AI will be capable to do that, and so we have some kind of our copy of ourselves that is completely virtual?
I think you're talking, let me just see if I understand you right. You're talking about using machine learning algorithms to, that type of AI, to store the personality of a deceased person. Is that right?
No, I'm not speaking generally about sick person. I'm speaking in general about any person.
Yeah, that's what I mean. So storing a copy of a person to sort of replay that person maybe down years later.
Yeah, and do you think is that ethical?
Is it ethical? I thought you were asking
That's
if it
the
was
second
possible.
question. Sorry for asking two questions in a row, but
Well, that's from what the computer scientists I talk to say, that's theoretically possible to store that, but not now. Maybe in the future. So that's a big if. And if that happened, then the ethical nature of that, I think we'd have to explore it when we find out how the AI is built, actually, and how it actuates. But yeah, I think that the big issue there, if it were me, I mean, if somebody, I'd want, first of all, to be very careful about getting permission of the person that you're recording or replicating, and also have some kind of duty, some kind of contract about how that replication is going to be used. Because otherwise, if somebody records me in all of my, essence, that could be used in all kinds of ways, especially after I'm dead. As for instance, it could be used as the basis for a DALL-E replication of me that would tell people to hate each other, on the internet. Yeah, I don't want that to happen. So it gets complicated, you see, when you start thinking about possibilities for how that would be used. So yeah, I think there'd have to be a bigger discussion about this, especially if and when we're able to do that.
okay, thanks.
Thank you very much. Somebody else? No? Thank you, Dr. Kevin. It was really, really
Thank you.
nice presentation.
Thank you very much. Thanks, everybody.